A very warm and pleasant good morning to the students. Today we are going to start a new topic, that is types of chemical reaction. There are basically four types of chemical reaction: combination reaction, decomposition reaction, displacement reaction, and double displacement reaction. Our first type is combination reaction. In a combination reaction, two or more element or compound combines to form a new compound. Here is an example. Calcium oxide reacts vigorously with water to form slake lime. Calcium oxide, that is CaO, reacts with water to produce CaOH2, that is slake lime, or you can call it calcium hydroxide. A reaction in which a single product is formed from two or more reactants is known as combination reaction, as I have said. Another example for combination reaction are burning of coal. Carbon, which is C, plus oxygen O2, which is always used in burning, reacts to form CO2, that is carbon dioxide gas. Another example is formation of water from H2 gas, hydrogen gas, and O2 gas, which is oxygen gas. Hydrogen gas combines with oxygen to form water. A large amount of heat is involved. This makes the reaction mixture warm. Here is an activity given. Take a small amount of calcium oxide or quick lime in a beaker. Slowly add water to it. Calcium oxide is basically a heating compound, so when we add water to it, it reacts vigorously, and you will observe that the beaker will get heat. When you touch the beaker, you feel heat filling in it. This type of reaction in which heat is released is known as exothermic chemical reaction. Examples of exothermic reactions are burning of natural gas, which is CH4 methane, 2O2, that which is oxygen gas, and produces CO2 carbon dioxide plus water. You heard about respiration process? It is also an exothermic process. In it, as you know, we need energy to live. We get this energy from the food we eat. During digestion, our food is broken into smaller substances. The example of some of our food is rice, potatoes, bread, which contains carbohydrates in it. The carbohydrates are broken down in the form of glucose, and the glucose combines with oxygen in our cells, which is the blood cells in our body, and provides us energy. This process is known as respiration. This is the reaction for the process of respiration. Respiration reaction. It is glucose combines with oxygen in our cells to produce carbon dioxide and water plus energy. The decomposition of vegetable matter into compost is also an example of exothermic reaction. Now, our second reaction type is decomposition reaction. In decomposition reaction, one reactant or compound produces two or more reactants in the form of product. As an example given, ferrous sulfate, which is green in color, when heated produces ferric oxide, which is Fe2O3 plus SO2 and SO3. In this reaction, you will observe that single reactants break down to give simple product. This is a decomposition reaction. Ferrous sulfate crystal, which is FeSO4, 7H2O, loses water when heated, and the color of the crystal changes. And then decomposition of ferric oxide, sulfur dioxide, and sulfur trioxide. Ferric oxide is a solid while SO2 and SO3 are gases. You can observe that it is solid, but these are in the form of gases. It dissolves, it reacts in the presence of heat to produce SO2 and SO3 in the form of gas. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction. Calcium oxide is also known as quicklime or simply lime. Uses of calcium oxides are they are used in manufacturing of cements. When a decomposition reaction is carried, there are three types of decomposition reaction. First is thermal decomposition, second is electrolytic decomposition, and third is photolytic decomposition reaction. In thermal, they are linked to each other. Like in thermal decomposition, when a decomposition reaction is carried out by heating, it is called thermal decomposition. It is simply by its name also. Thermal means heat. That's why a decomposition reaction in which heat is involved. Simply in electrolytic decomposition reaction, a decomposition reaction in which electric is involved or electricity is involved in a thermal decomposition. Similarly, in photoelectric decomposition reaction, it is when a decomposition reaction is carried out in the presence of sunlight is known as photoelectric decomposition reaction. An example of thermal decomposition reaction is CaCO3, that is limestone, when heated produces quicklime and CO2. Here is an activity given, that is we have to take a burner, test tube, a tongue and a lead nitrate solution in it. Simply place the test tube above the burner and burn it for some time. Placing the lead nitrate solution in it, you will observe that brown heat waves are coming through the test tube. The reaction for the activity 1.6 is given below, that is lead nitrate PbNO3 when heated, as you can see here, produces lead oxide, that is 2PbO, and nitrogen dioxide plus oxygen gas, which are produced in the form of these red flames outside the test tube. Now there is another example. We have to take a china dish and place silver chloride in it. As we can say that the color of silver chloride is white, but when the sunlight falls on the solution of silver chloride, its color changes into grayish. The reaction for this activity is given here. It is activity 1.1. It is very important activity. Always board asks for this question: what is photoelectric decomposition reaction and equation of silver chloride when in the presence of sunlight? The formula of silver chloride is AgCl. When in presence of sunlight reacts to form silver and chloride. Silver bromide also behaves in the same way. AgBr in presence of sunlight reacts to form silver and bromine. The above reactions are used in black and white photography. As we have seen here, the reaction in which heat is evolved is known as exothermic reaction. Similarly, a reaction in which energy is absorbed or heat is absorbed are known as endothermic reaction. There are some more in-text questions you have to do like the same way as you have done all this. Our next reaction type is displacement reaction. In displacement reaction, one element or compound displaces or removes another element to form a new element. It is known as displacement reaction. As you can see here, in a test activity is given, take a test tube, put two iron nails in it, add copper sulfate solution in it, a thread from which the iron nails are hanged, and test tube. You will observe that the iron nail color has been changed because it removed all the copper present in it to the solution, and the color of the solution from copper sulfate, the color of copper sulfate is blue, but it is changed into light green color because only copper is present in the solution. The sulfate has been removed and placed at the surface of the iron nail. The equation for the reaction for this activity 1.2.3 is given here. Iron, that is Fe, plus copper sulfate CuSO4 reacts to form iron sulfate, that is FeSO4 plus copper Cu. In this reaction, iron has displaced or removed another element, copper, from copper sulfate solution. As you can see that Fe is here alone, but copper removes sulfate from it, and the sulfate from here now jumps into Fe and produces FeSO4. Some other examples are zinc plus copper sulfate. From now, copper removes sulfate from here, and the sulfate will attach into zinc and produce a zinc sulfate that is NaSO4. Similarly, in this example also, Pb plus CuCl2. Here copper releases Cl2 from here, and the Cl2 will attach with Pb and produces PbCl2, that is lead chloride. Zinc and lead are most reactive elements than copper. They displaces copper from its compound. Now our fourth reaction type, that is double displacement reaction. In double displacement reaction, exchange of ions takes place. Here is another type of reaction given, that is precipitate reaction. In a precipitate reaction, a reaction which produces a precipitate called precipitate reaction. An example of it is given here, like Na2SO4, that is sodium sulfate, plus BaCl2, barium chloride, produces BaSO4 plus 2NaCl. The sulfate from here linked with barium, as barium has positive charge in it and sulfate has negative charge in it, so the charges interact each other, and sodium will combine with chloride and sulfate will combine with barium, so they will produce barium sulfate and the remaining compound, that is NaCl, which is also known as salt. It is white in color and it is soluble in water. Reaction in which there is an exchange of ions between the reactants are called double displacement reaction. Here is our next reaction type, that is oxidation and reduction reaction. In oxidation reaction, if a substance gains oxygen or reduces hydrogen, it is known as oxidation reaction, or simply if a substance gains oxygen, it is known as to be oxidized. Similarly, if a substance loses oxygen or gains hydrogen, it is called reduction reaction, and if a substance loses oxygen during a reaction, it is said to be reduced. An example is given here. An activity is also given. Take a china. We have to take a china dish, place copper powder in it, and put a burner, a tripod stand, and burn it. After some time, you will observe that in the present, the copper will react with the oxygen of the surrounding and produces copper oxide. The reaction for it is given, that is copper in the presence of oxygen when heated produces copper oxide. Here copper gains oxygen, it means copper is oxidized. But if we pass hydrogen gas through it, again hydrogen gas through the copper oxide solution and heat it, then the copper metal will shape red and we will obtain our pure metal again, and water is released. In this case, copper is reduced but hydrogen is oxidized. This type of reaction is called the oxidation and reduction reaction, or simply redox reaction. Such type of reaction in which one reactant gets oxidized while the other gets reduced during a reaction. This type of reaction are called oxidation reduction reaction or redox reaction. Some of the example of redox reaction are given below. that is ZnO plus C, reacts to form Zn plus CO. Here also, if a substance gains oxygen or loses hydrogen during a reaction, it is oxidized as we have seen here. Similarly, if a substance loses oxygen or gains hydrogen during a reaction, it is known as reduced. Have you observed the effect of oxidation reaction in everyday life? Corrosion. First is corrosion. You must have observed the iron article or shiny when new, but get coated with a reddish brown powder when left for some time. The process is commonly known as rusting of iron. As you can see, I have an example for you all. It is an iron object, but it is shiny. But after some time, when we left it in the surrounding, the air, the oxygen from the surrounding and the moisture will stick to its surface and makes it corrode, and a brown element will stuck to the surface of it. As you can see here, the process is called corrosion. This process is called corrosion. When a metal is attacked by substance around it, such as moisture, acid, it is said to be corroded, and this process is called corrosion. There are many examples of it, like silver. As we left silver in the surrounding, like I have placed the iron in the surrounding, you will observe that a black coating on the silver will appear after some time. Similarly, in the case of copper, a green coating will come on the surface of the copper. Corrosion causes many damage to the metal bodies. A large amount of expenditure money is spent to replace the iron from the surrounding. Another type is rancidity. When fats and oils are oxidized, they become rancid and their smell and taste change. Usually, substances which prevent oxidation, antioxidants, are added to food containing fats and oil. Keeping food in airtight container helps to slow down oxidation. When we left the food in the surrounding, its taste changed. It seems to be tasteless, but to cure this, we can keep the food in airtight container so that the air from the surrounding don't get in it and spoil it and make it rancid. Similarly, we can also add antioxidants to the food to become them unrancid. We can also put the food in the refrigerator, and we can also put nitrogen oxidants in it to be not to become them rancid. So here are another interest question. These are all for you to complete it, and I will be providing notes for all the chapter in our next video. So kindly note all the notes in the your copy, and I will provide question answers too.